100, right? I hope you are getting this particular part. Everything is same, just the thing is that we are just connecting an AC source instead of function generator, so that we would get an appropriate frequency response. Okay, so just remember one thing: when you are plotting a frequency response, always prefer to connect a voltage source. Don't go behind or behind the function generator. Okay, now where we want to see the frequency response at the output side, right? So basically we are taking output at channel B. Okay, so we are connecting the collector of transistor Q1 to the positive terminal of channel B, right? So that means this particular terminal, right? So just right click on this particular terminal. Okay, see, I'm taking output from this particular terminal, so I'll just right click on it and I'll go to the properties and just see the number of this particular wire. It is 4. Okay, just remember this particular number, it is 4. Okay, it is 4. Just cancel it. Okay, so now to plot the frequency response, go to this particular option, that is simulate. Just click over here and then go in analysis and simulation. Okay, and then go to the AC sweep. See, I will again repeat the entire steps. First, what you have to do before going to this particular part, you just need to understand what is your output. So in this particular circuit, my output is channel B. Okay, so I'm connecting the output, that is collector of transistor Q1 to the positive terminal of channel B. Okay, that is oscilloscope. Okay, positive terminal of channel B of oscilloscope, right? So I'll just right click on it. Okay, and then I'll go to the properties and I'll just check the name of it, or net name, or the number, that is 4. Just remember this particular number. Then go in the simulate option and then go in analysis and simulation, and then okay, go in AC sweep. Just click over here. Okay, and just look over here, this particular option, that is vertical scale. That means it is talking about this particular scale. See, it is talking about this particular scale, vertical scale. It should be in dB, as I had already mentioned. It should be in dB. So let me erase it. Yeah, so it should be in dB, so we need to change it to dB, that is decibel. So this is the only thing I need to change. Okay, apart from that, you don't need to change anything over here. The starting frequency should be 1 Hz, that is fine. The stop frequency should be 100 gigahertz, that is fine. Okay, don't change anything over here. Okay, the only thing we need to change is that we need to keep the vertical scale at dB. Okay, and then output, come in output and then find the number 4. So you can clearly see over here we have number 4, V4. See, V4. Okay, just click on this particular V4. Don't select I4, otherwise we will get current. We don't want current, we want V4, we want voltage, V4, and then click on add. Just click on this V4 and then add. Why 4? Because we had already seen the net name, which was 4, right? And just add. Just click on this particular button, add, and then save, and then run this particular circuit. You will get the exact frequency response, and this is the frequency response. See, the above one is the frequency response. Let me just just click on this particular option. Okay, if you want the screen to be completely white, just click on this particular option, which is available over here below the legend option. Okay, just click over here. Okay, so you will get the entire background in white. This is the phase response, or the phase response, that is phase, the plot between phase and frequency. As of now, this is not a big concern for us. We really don't want this. So what I'll do is that I'll just right click on it and I'll just delete this particular graph, because we don't want this particular graph. Okay, so this is the graph which we wanted, and you can clearly see over here we are getting gain of around 45 dB. Okay, see, theoretically what we got is that the gain was of around 40. So this is the theoretical value, right? So this particular value, it is theoretical value, but practically we are getting gain of around 45 dB, which is absolutely fine. So this particular value is also fine. You can clearly check over here we are getting the, let me just first save it. Okay, let me just save it and we'll just go over here. So you can clearly see over here this particular point, it is roughly around 45. So this is around 45 dB, right? So this is around 45 dB, and theoretically we should get 40 dB. That means this particular curve should look something like this, theoretically something like this. Okay, but practically we are getting curve something like this, which is also fine. So that means whatever circuit that we had designed, okay, depending upon the user specification, that is absolutely fine, that is absolutely correct. Okay, and as I told you, see, even if the frequency is around maybe 1 Hz, see over here, even if the frequency is 1 Hz, still it is providing the gain of 40. That means around 1 volt peak to peak signal, right? 1 volt peak to peak signal. Even if the frequency is 100 hertz, you can clearly see over here, still it is providing same gain. Even if the frequency is 10 hertz, still it is providing same gain. Even at 1 megahertz, it is providing same gain. But if you look over here, maybe somewhere over here, I think this frequency should be of around 10 megahertz or 50 megahertz. So from this particular frequency, the signal starts to attenuate. Okay, the signal starts to attenuate. If you want to check what that frequency is, so click on the AC sweep and then click over here, show cursor. Okay, and then move this particular cursor, and somewhere over here at this particular point, over here, yeah, you can clearly see over here, see this particular value, this is x2. See this one, x2 means over here, it is talking about this particular point. The frequency is 14.868 megahertz. So at this particular frequency, like even if the if the frequency goes beyond this, maybe if the frequency is 15 megahertz, so the entire signal gets attenuated. So you can clearly see from here, after 15 megahertz to be precise, the signal starts to attenuate. But from 1 hertz to maybe 15 megahertz, the differential amplifier amplifies the signal properly, amplifies the signal with constant gain, constant gain. I'm writing it little roughly. If you want, you can write it in your notes properly. Okay, so let me erase it, and now we will move to the frequency response of the CE amplifier. So let me move to the frequency response of the CE amplifier. Just a second. Yeah, so you can clearly see, just a second, this is my CE amplifier, and this is the frequency response of the CE amplifier. You can clearly see over here as well, we are almost getting a gain of around 45 dB. Just a second, let me move it somewhere over here. You can clearly see over here, this is, let me just draw this particular line little roughly. So it is around 45 dB, roughly around 45 dB, right? But the main thing to notice over here is that, before this particular frequency, maybe when the frequency is around 300 hertz, let's assume this is around 300 hertz. So if you are providing a signal of around maybe from 1 hertz to 300 hertz, the CE amplifier, it is attenuating this particular signal whose frequency lies between 1 hertz to 300 hertz. But if the frequency is between 300 hertz to maybe, what is the frequency over here? Maybe 1 megahertz to be precise, 1 megahertz. So it amplifies this particular portion. Okay, it amplifies properly. It amplifies the input signal. I hope you are able to understand this particular part. Okay, and if the frequency goes beyond 1 megahertz, so again it will attenuate the signal. But the main thing to notice over here is that in differential amplifier, differential amplifier amplifies the signal whose frequency of around 1 hertz. Okay, let me erase all of the ring. So you can clearly see, once again I'm repeating, let me just okay, just a second, okay. So what you can clearly see over here is that even if the frequency of the input signal is of 1 hertz, still the differential amplifier will provide the gain of around maybe 40 dB for that particular input signal of 1 hertz. Okay, that means even if the input signal is of 1 hertz, so the differential amplifier will amplify the signal with the gain of 40 dB. Whereas if you could see in CE amplifier, if I am providing the input signal of 1 hertz, so the the CE amplifier would not provide the gain of around 45 dB or 40 dB for that particular input signal whose frequency is around 1 hertz. If the frequency goes around maybe 400 or 500 hertz, then only the CE amplifier can provide a constant gain maybe up till 1 megahertz, and after that it will again attenuate. Okay, so that's the big advantage of differential amplifier over CE amplifier, because in CE amplifier we are connecting capacitor. You can clearly see we had connected capacitor in CE amplifier, and that's why this particular capacitor plays an immensely important role to decrease the gain. Okay, decrease the gain if the frequency of that particular signal is less than 100 hertz or maybe 20 hertz or maybe 300 hertz. because capacitor blocks the DC signal, and for capacitor this 100 hertz and 200 hertz, it's a very less value, right? Whereas if you could say in case of differential amplifier, just a moment, yeah, in case of differential amplifier, you can clearly see we had not connected even a single capacitor, and that's why it is able to amplify the signal of very less frequency as well. That means 1 hertz, 10 hertz, 20 hertz. Okay, so I really hope that you understood like why we use differential amplifier, where we use differential amplifier, what is the significance of differential amplifier over CE amplifier. Okay, how to plot frequency response of the differential amplifier. Okay, like, and why we use dual voltage supply. Okay, why we use 2 transistors. Okay, how to provide a dual supply to the input of the differential amplifier. Okay, and this significance of differential amplifier over any other amplifier. Okay, so I really hope that you understood each and everything that we had discussed in this particular course of the differential amplifier. Okay, so this was the last session of this particular course, and I really hope that you understood each and everything that we had discussed till now. Okay, so if you have any doubts, if you are facing any difficulties anywhere, maybe in the frequency response, or if you are not getting the plot of frequency response on the Multisim software, you can actually put the comment in the comment section, and I will surely reply it to you. Okay, so thank you for listening me patiently. I really hope that you understood each and everything that we had discussed till now. If you have any doubts, if you are facing any difficulties anywhere in the entire course, you make sure to ask me in the communication section. I will surely help you out there. Okay, so thank you for listening me patiently. I am ending this video over here. Thank you.